On laisse quelques minutes. On n'a pas vraiment de temps.
Non, on n'a pas longtemps. 30 secondes. We start in 30 seconds. We have a full agenda once again, so we don't want to take too much delay at the beginning. Otherwise, we'll run into problems at the end.
Et combien de gens sont invités quand?
1, 2, 3, 4, 5, 5 people.
Est-ce qu'il y a Muriel?
Yeah. Emmanuel, Kevin, Morton, Muriel, Juan.
Cool.
Perfect. Belkacem will also join us. Okay, so I think we can start.
Okay, so this is the Coding for Efficient Network Communications Research Group. Again, like Vincent said, we have a very full agenda. Changer the slide. Next slide. So for people who are new here, our goal is essentially to foster research, and I would, emphasize the word research here, in network and application layer coding to improve performance. What does that research mean? It means research in codes and coding libraries, and you're going to hear about some of that in the early presentations here. We also want to focus on protocols that will facilitate the use of coding in existing systems. A lot of times the reason that coding is not used is because there's not an easy way to access this code from inside another protocol. And we want to look into real-world use cases and also work in progress in other working groups and in other research groups and outside our group also.
Okay, so now the usual not well slide. In fact, not exactly the usual because it has changed recently, but the underlying documents remain the same. So I don't want to go through this slide, just to highlight one of the points that is still very important in our case. If you are reasonably aware of IPR related to your work or work from somebody else, then please, you need to do an IPR disclosure rapidly. You can have more details in BCP 79 at the end of this list. BCP 79, best current practice, is also a short name for another name for RFC 8179. So have a look at that. Then concerning some administrative stuff, if ever you are looking for any information, any piece of information concerning our research group, then you need to go to the data tracker.ietf.org website. Everything is there. The documents, the milestones, the agenda, the charter, everything is there. Okay. We also have a wiki, but we are not using it so much for the moment. Mailing list. The slides are all uploaded, except maybe one of them, but I hope that we'll get it. This is the Jan presentation, but he will send it to us. All the slides otherwise are available online, and of course, remote participation is through the usual Miteco system. The agenda, as I said, is pretty full. We have a 0 time balance. So if you intend to present something, then make sure that your presentation is stay within the allocated time. So we have, except one exception, a quarter of hour for each of us, 10 minutes presentation and 5-minute questions. If you spend more time presentation, it means less time on discussion. Up to you.
Okay. So a little bit of a quick status about what is going on. We have a document that is at ISG review, which means that it will be in RFC very soon. And it's the network coding taxonomy, which describes the words that we are using and describes a lot of the functions of network coding. There are currently individual ideas. Tetris has one. There's RLNC. There's a presentation that's going to be here presented today that has both information about RLNC and also about symbols. There is it's not very good here. Anyway,
there's no problem.
There is
network coding satellites.
Network coding and satellites. And actually, this is an update to work that was done before. There's also an update to network coding in ICN, which was also going to be presented today. We have the work on the Common Coding API, and again, we're going to talk about that a lot today because this is something that is needed to allow interoperability. Something that we haven't really talked about much is the network coding adoption challenges, which we have not a draft yet. Network coding and congestion control, well, we're going to have a presentation today. There was not a real document submitted. And this idea of network coding and robust tunneling, I think this will going to be probably changed to network coding and quick, because this is what I think the original idea of the robust tunneling was there. So future meetings, we plan obviously to have a meeting in Montreal in July. And we're also planning to have an interim meeting. The tentative date is September 25th in Boston. Last year when we had an interim meeting in that time frame, it was extremely successful because again, there is a critical mass of network coding companies and network coding users in the Boston area.
Remote participation will hopefully be possible, but being there is always better.
Yeah, well, and it's lovely in Boston in September.
Yes. Okay, so that's for the agenda. So let's continue with the first presentation. Jonathan.
Yes, that's okay.
So we have a bunch of presentation concerning the various building blocks, and then we'll continue with the second part of this meeting with use cases.
So we uploaded the fourth version of the Tetris draft. So this presentation is not about the Tetris protocol, it's more about the internet draft itself. So what do we do with this? So next slide, please. So just do not well. Next slide. So the objective of our work is to propose a generic transport protocol framework plus some building blocks, and particularly the elastic encoding window. Next slide. And today, everything is inside the same document. So we define the protocol, so we define some packet formats, and we also define a set of building blocks. So everything is inside this document, and this is why I want to discuss. You will see at the end. Next slide. So Tetris is defined as an application layer transport protocol. So it's end-to-end and above UDP. Next slide. So the use cases are unicast and multicast communications with or without feedbacks. So in the protocol part, we make it simple. So we have 3 packet formats. So the first is the source packet. So it's just a payload with an ID. The second is a coded packet. So it's a linear combination of some source packets and including an ID plus an encoding vector. So the information about the linear combination plus the coded packet payload. The last one is the acknowledged packet. So we provide some feedback like packet loss rate, the missing packets, or anyone who want to go back from the decoder to the encoder. So next slide. Okay, so we propose this encoding vector. So this could be actually the first building block. So this is the most important because it defines how we code the data. Okay, so each coded packet contains an encoding vector. So we wanted to create a generic encoding vector. That's why by using this format, you could store the source ID you include in the coded packet. You could store the coefficients, but if you want, you don't have to put the coefficients. So in the next slide, I will make an example. So for example, if you just want to use a sliding window, so suppose you want to generate an encoding vector by using the sliding window of size 64 by using the finite field with 2 to the power 8 elements. So you want to code symbol source 0 to 63. So you actually need 8 bytes to store all the information about the linear combination. Okay? So you don't have to actually store all the coefficients, because in the draft, we defined some algorithms, some deterministic methods to generate the coefficients. So this encoding vector could be one of the building blocks. Next slide. No, before. Yes. So another building block could be the generation of the coefficients. So in Tetris, we propose one approach, which is a deterministic way. So basically, you are inside a coded symbol I, and you want to generate the coefficient to integrate the source symbol J. So you have defined in the draft a method to just generate directly the coefficient based on these two ideas. So you don't have to generate all the coefficients for your full linear combination. You just, if you want, just generate one coefficient, it's possible. So this is an approach we propose. Okay, it does not cover all the use cases in the network coding, but this is what we propose. Next slide. Okay, so now, as I said, everything is inside the same document. So now, what do? Do we have to split the document between the protocol and a set of building blocks, or do we have to continue with this generic framework, or do we have to create some internal draft by defining more precisely the building blocks, like the encoding vector or the generation of coefficient? So it's up to you to decide.
Dave Oran, Network Systems Research and Design. Just a clarifying question. Could you explain to some of us that don't follow all the details what the inner overlap, if any, in field of applicability between this and the TSV encoding draft for sliding window RLNC that's happening with the FEC frame work?
So basically, this is another format. Exactly. So we defined a format. I think FEC frame of RLNC defined another format. So we have some common information, but it's another format. So,
do we need to worry about defining the meta problem to give people some guidance as to, which approach to use in what field of applicability?
Marie-Josée Montpetit, without my chair hat, I think we've had some discussions with a lot of the people, and actually also I'm the co-author of another draft. And I think what we would like to get as much as possible is a set of generic protocol blocks that we would say, we call them the open source APIs, and then having a set of specific blocks that are code dependent and actually could be more or less transparent and more or less open. So I think there's a lot of overlap, Dave, between the applicability of each of these things, but we would like also to allow them to be used both independently or to address the same problem, but then you could choose whatever you want. Does that answer your question? Because it was not a question that much for him, but I think for the generic group.
I think it answers the question. I'm not sure I like the answer very much.
Okay.
In the sense that we don't have neither document seems to provide any guidance as to which one might be more appropriate for any given thing. And you mentioned APIs. This has nothing to do with APIs. This is protocol encoding, right? And you could provide a generic API that could do either of these things, but then who decides when you call that API which one gets used, right? So I just think there might be some meta work to be done to give the community some guidance. And I don't have an opinion as to whether technically one's better than the other for this or the other, but one of the things we can do in a research group, since we're doing research, is maybe some experimentation that later can provide some guidance to people as to what the right field of applicability for the different encodings might be.
Yeah, Vincent, without my chair hat, but also as co-author, main author of the fake frame stuff. That's a very good point. And you will see there is some overlap between this presentation, the presentation that will appear just after on packet header formats, and also some overlap with what I've done with colleagues in the context of FakeFrame. For FakeFrame is a bit special because it was focused on already existing protocol with some specificities. But yes, there is some commonality, and we need to have a common understanding and guidance regarding how to format headers in an appropriate way to fulfill the requirements of that on this and that protocol. So yes, this is work that we need to be done, and we wanted with Marie-Josée to put that explicitly on the table after the second presentation.
Yeah, I'm sure there are really good reasons to have these different things, but somebody coming at it from the outside,
Yeah.
right, is not going to have a direct line into, the brains of the people that did this thing. So something that explains that.
So
would
again,
be
this is
very
Marie-Josée.
useful.
It's very funny because this was our lunch discussion. And
Yeah.
we intend to promote that type of work. So after this meeting, we intend to start a discussion on the list about how this is going to take shape and what contributions will be.
Yes. Yes, Muriel?
Yes, I had a question about recoding. How do you envision recoding here?
So basically, as I said, it's end-to-end. So we wrote a part about recoding in the draft, but it will be removed in the next. So basically, we want only to focus about end-to-end without recoding.
Thank you.
You're welcome. That's all. Comment, questions?
More questions?
Okay, so then in that case, let's continue with next presentation, and then maybe we will come back on this question on
Yeah. Of what to
protocol headers and all
Yeah.
these aspects. So, yes.
Can I press that one?
No, I did not. So just tell me. You have the floor.
Okay, good. Hello, thank you to the chairs, and thank you to the other authors. So Merle, who is with us remotely, and Shirley from Codon, and myself from Steinberg. And can you hear me? No, can you hear me now?
Yes.
Okay. So, and Vince from Inmarsat. So can you give me my first slide? Okay, so the agenda is essentially a general motivation and the objective of this work, and the design goals and features that we support, and then an example of the simple representation that we have proposed and some types, and the relationship with the outer protocol and some limitations of this work. So it's related to the first presentation a lot. So the starting point of this work was that we wanted a general purpose, a very low overhead representation of coded symbols. So it's not a protocol, it's just the symbols with some stuff on top so that you can interpret them at the receiver. So, sorry? Okay. Maybe I need to be really close. Is that better now? Could I get the next slide, please? Could I get the next slide? Thank you very much. So the motivation, so the representation of the symbol is very small, but it's an important part of any protocol using network coding. So
could you speak loud?
Should I just
louder or closer to the microphone? Because I don't even hear you.
Okay, so maybe I just don't use the microphone. Is that better?
No, we need to use the microphone.
Oh, you need to. Okay, sorry. Okay, so maybe I just. Okay, so try this one. Okay, so yeah. So the motivation is a representation of a coded symbol that because we need that in multiple different protocols, and we can reuse that, so we can build our protocols faster. We don't need to redefine this every time, like the last and also the chairs noted. And then it can give us some interoperability between implementations of the underlying code, so the coding libraries and stuff like that. And then this last one should maybe be on the next slide, but at least it was important for this work that we wanted to accommodate a varying frame size over the course of the transportation, over the life of the transportation, because we are working on a network where that happens to be the case, that the underlying frame size changes because of some changing link conditions. So next slide, please. So we have the goals here. The low, we want a low header overhead. Very low, we want to support recoding because we think it's an important feature of network coding that we need. And we want to be able to generate symbols from blocks that are incomplete in case of a block code. And we want to support both a block and a sliding window type of code. So the features that we have included as a consequence of this is a variable number of symbols that can be represented in each of these representations, because usually we have fixed symbol size, and that means that the only thing that we can vary is the number of symbols we put into each representation, unless we want a representation for each symbol. And if we have that, then we have an overhead for each of the symbols we put in. So that seriously limits the flexibility we have. We have 3 symbol types. So we have an uncoded and a coded and a recoded one. So similar to the first work that was presented. So we need different things for these 3 different cases. So in order to be efficient, we should define some different ones. And then we have a small and a large encoding window, which essentially limits how big we can do, how much data we can put in our blocks and in our windows. And then we have a bunch of parameters that we actually don't have in this protocol that can be defined per stream or per packet or per something else. And if we want to be most efficient, we cannot define those in this representation, because if they are, for example, the same during the whole life of the transmission, then it's a waste of bits. So here's a sort of a generic example, which is just a type field. We have these different types, and then we have a field for how many symbols we include. And then we have the rank at the encoder, which is necessary if you want to encode symbols before you have a full block, for example. And then we have something like a seed or a coding vector that we include, and the data that is encoded. Next slide, please. And then we have the 3 different types. So the first one is just an uncoded symbol. So there, the encoder rank is essentially an offset into the block or into the sliding window, and then there's some data that is appended. And if we have something that is coded, then we also need a seed, so that we can put that into the pseudo-random generator that we typically use when we do encoding at a source. So the seed can be used for all of the symbols inside of the representation, because we just keep on generating numbers. So we have a fixed overhead, regardless of how many symbols we put into the representation. And then in the case of a recoded symbol, we put in the coding coefficients, or if we have some system where we don't have access to the random generator or something else, you can essentially support anything. You can generate an arbitrary coding vector any way you want and put that into this representation, but it also has a higher overhead. So it's not what you would usually do. And the reason why we think that we need all of these 3 is we need to mix and match them in a system, right? That could be that most of the traffic is uncoded, and then there's a little bit that is coded or recoded or something else. So if we don't permit that we can change that they're interoperable, then we will not be most efficient. So in relationship to the outer protocol, maybe there is some things that we support, and we support that you can essentially put any number of representation into a single payload. And then in each of these representations, you can put in up to 15 symbols. And then we have 2 different window or block sizes that we supported. A small one up to 1,000 approximately, which is typically enough for block code. And then there's a really big one up to 260 something if you want maybe a really big sliding window. And then there's a bunch of things that the outer protocol needs to define for this to work. So it's things like the field, the symbol size, it's the type of representation that we use here, either small or large, and typically you would choose one for your application and then use that throughout. And then you need to also provide the block ID or the window offset in the outer protocol. And there's some things that you could define if you need them or if they are useful. That would be things like, for example, the block size or the density of the code. If you have something with a variable sparse code where you adapt to how your network operates, you could also define the pseudo-random generator if you want to. So yeah, that was, I think, next slide. That was it. Thank you for the attention.
Comments, questions? I have. Okay, so thank you for this initiative, because this is something that was missing into this group, having some document that describes, even if you don't go into the details for the moment, but that describes RLNC is something that was considered as important. We put that in the milestones, so that's great. It's also important to start discussions on protocol headers. And from this point of view, we need to work together. Well, I have several technical comments on your proposal. I don't think it's appropriate put in this way for various reasons. So we can technically discuss that. But, well, maybe it's not required to do that now in the meeting. We'll do that after if you want. But most importantly, we need to work together on this aspect between you, your colleagues, Jonathan, who also has something in the other document as we presented just before, and myself in the context of fake frame. I also have another type of formats. So there are 3 different initiatives that converge on this idea of having some common and reusable protocol headers or trails. Doesn't matter. So I would suggest to remove this part from this document, having a document that focuses solely on RLNC, having another document which is a building block on protocol headers, likely to carry this encoding vector to identify the content of the sliding window, if it is a sliding window code, having something different. And then for this second document, I would suggest to collaborate with you, with Jonathan, and with other people who also have their own ideas in order to find something that maybe could be usable, reusable in some way, maybe not for all the use cases, because, for instance, I was mentioning earlier that with fake frame, we have some already existing mechanisms, so we need to be compliant with that. So there are requirements specific to that, but otherwise, we can extract some ideas that are more or less aligned with what you presented, with what Jonathan presented. So working together in order to have this building block that could be reused in different contexts, if possible, as much as possible, I would say. Do you think it's something that makes sense to you? Well, we will discuss this also on the list. That's the meeting. There will be a minutes. It will be mentioned, but our goal is to have a common decision on those topics. It's not my decision as co-chair, for sure. But that's an idea that I would like to put on the table now. Yes, Jonathan?
Jonathan, so do you want a single document with all the encoding vector formats to represent a building block, or do you want several documents, or?
No, we need to have a single document that is that takes the best of all 3 proposals in order to find something which makes sense in as many situations as possible with as many protocols as possible.
So at the end, you want only one format?
No, I don't necessarily want one format. Okay. It depends. I don't have the answer today. It depends on protocol requirements. In that case, we maybe have to use that format because it makes sense. In another case, we'll have another format. But at least having a single document and see how far we can go into this direction. Having something common as much as possible. I don't know if it is. I don't have the answer today. We need to think about it together, but let's try to work together. I think it's better than having your document with all the stuff inside and Jonathan's document with all the stuff inside. Let's split things. Muriel first.
Yes, I think that actually Jonathan sort of asked my question. So what you're looking for is you would like to have from the group a general format document. Is that what you're suggesting?
A general format is possible, but at least let's work on this.
But one document.
Yeah, one document for sure.
Different formats.
With this building block, this header building block.
Okay.
Okay, you're welcome.
So basically,
So I think the goal is a good one, but at the end of the day, we need at least one form of global optimization, which is that if we have n formats and m protocol embeddings, we have an order n times m problem in terms of actually putting a system together. So the caution I would give by splitting this out is that we don't run two parallel efforts, each of which is operating in its own degree of freedom, right? So that we wind up with a cross product that's, unimaginably large, right? So we can decide whether to constrain the number of protocol embeddings we have or constrain the number of formats we have or both. But if we don't constrain either one, we're going to, we've seen this in the IETF and other places before. You wind up with a gigantic mess.
Yeah.
So some global discipline is needed here.
Yeah, good point.
Good point.
So if we do that, it means that we would have this RLNC document, this building block dedicated to formats, and another
Can I
document.
go in 1 second? I must have missed something because what in that document, this format document, was actually specific to RLNC?
No, yes, I should have mentioned that before. And when we read this document, we see that there is a lot of text describing in some way general concept related to RLNC, and then we have format part. This is the way I understand the document. So let's split that
I thought there was a
together
lot of description of RLNC as the use case motivating the format. I just want to do a test because I didn't see anything in the actual format that was specific to RLNC. Am I right or wrong?
Janus, if you want to answer.
Yeah, so for example, it depends if you compare with one like a normal block code. Usually you wait until the block is full and then you start coding, right? So this encoder
But you could still use a symbol representation.
Sure.
Okay.
Yeah. So it's you can use that
as a symbol representation. All right. I could be wrong. I just didn't see anything specific to RLNC in the coding.
This is the idea of conveying the coding coefficients.
If it wasn't RLNC, you would never have a recoded block representation. But systematic code will have, whether it's RLNC or not, will have uncoded format, symbols and coded format symbols, right? And
true, but
a non-systematic code would only use coded symbols.
But you wouldn't, for example, need to communicate the rank, right, at the encoder in a normal block code, for example. So
it's a superset.
Yes.
Okay.
Yeah. Muriel has a question, comment.
I had a couple comments. So yes, I completely agree with Dave. That was a motivating example, particularly, for instance, for recoding, but nothing here is specific to RLNC in terms of the format. And conversely, I just wanted to point out that there have been proposals, and indeed my group has had papers on doing RLNC without conveying the coefficients, because there are other ways of figuring out the coefficients implicitly or predetermined. I think what you would have called deterministic, maybe in the previous presentation. So it's a motivating example, but it's for particular. It enables certain things that are like the recoding, which are particularly nice with RLNC. But it is really just a generic format that happens to enable certain of the RLNC cases that we have found to be very effective. So does that place it? It's not really a subset or superset. It's just a set of encoding formats which we think are generally useful, and the RLNC is just there as one of the cases for some of the implementations of RLNC where this is useful. Does that make sense to everyone?
Yep.
Okay.
Thank you. So it also means that you, Jonathan, should produce a new version of this document, going towards something which is more generic in terms of protocol mechanisms, with building blocks like header formats that are moved elsewhere in this document.
Yeah, sure.
Next meeting.
Sure. Okay. So the only difference between recoding and not recoding is you just need the coefficients to be inserted inside the packets, right? I think this is the only difference. So I'm pretty sure we could imagine a format, generic format with an optional field, and you said, okay, I want the coefficient inside, so or I don't want the coefficients. So it should be pretty simple to converge.
Yes, Muriel?
Yes, so the recoding doesn't always require that does not always require the conveyance of the new coefficients upon which the recoding is effected. So, you know, on the other hand, of course, there's some really great use cases for it. But again, it's not a sine qua non condition. I just wanted to make that clear. And indeed, some of the papers that my group had early on sensor networks, what people generally call more IoT right now, indeed did not, did use recoding without conveyance of the header, without conveyance of the coefficients in the header. Okay.
Yep.
So I just wanted to point out. Yeah, that's all. Thanks.
Thank you. Okay, so I think we are almost done. Just one comment, because we already had some discussion offline on this topic. But if you believe there is an IPR disclosure that should be done on this document, please do that rapidly as possible. There is an exact wording in the BCP 79 that says as rapidly as possible after document submission, after contribution. So please keep that in mind. One more comment regarding IPR disclosure. If the patent is not yet granted, it's not a problem. There is a checkbox where that can check to say, okay, this is a non-published pending patent. So I don't know what is the situation, but if we can clarify this rapidly, that would be great.
Yeah,
Thank
sure. Gianmarco Tasca, Codon. We are working on the IPR disclosure. We understand that, it should be disclosed as reasonably as possible, not as rapidly as possible. You should appreciate that, the IP is owned by predominantly MIT and Caltech, but there are also other 8 universities involved. So we are discussing and agreeing the best licensing strategy and approach. But, we are working on it, and,
Okay.
soon should be submitted.
But you confirm that there will be an IPR disclosure on this document. That's one point.
Yes,
Yeah,
confirm.
okay. Thank you. That's one part of the answer. Thank you. So, no more comments? Okay, so let's continue. Wait. This is my turn.
Attends, mais t'as pas mis pleine page. T'as raison. Voilà.
Okay, so I would like to talk about this document, which is about a generic API for low-level FEC codes that could be used in this context. So it is joint work with Jonathan, with Morten, with Cedric, with Jan. Yes, next. And I updated this document only very recently, yesterday, in fact. Sorry for that. I will try to do better next time. I was waiting for a third contribution. So now this document, the one you will find on the data tracker, includes 3 example APIs for sliding window codes. Mine, the one from Jonathan, and the one from Morten. So those 3 APIs correspond to running codes. There is something behind them. They have been independently developed by the 3 of us plus colleagues. Of course, we are not working all alone, but they have been independently developed. So that's something very precious. And there is also a link to a 4th implementation of sliding window codes, the one from Cedric, which you can find the URL here. This one does not include a codec API. It's developed in a different way. There is no standalone codec. So I mentioned it. We can use it to get inspiration. We can also discuss with Cedric, who is well aware of how we can do that. But it was designed in a different way. So there is no fourth. There are only 3 examples, not 4. Anyway, so we have analyzed all of them, and we came with a few preliminary conclusions on several questions that I would like now to introduce to you. They are not in the document. So first of all, I would like to do a reminder before going into the details. We need to understand that what we are looking here is an API for a low-level codec. Low-level codec will include a certain number of mechanisms, but certainly not all of them. A lot of stuff will remain in the caller, in the application, or in the protocol that will use this low-level codec. So we have the codec API in between, but a lot of stuff will be out of scope for this API. So you will see in the future slides, some of them, some of the questions that we try to answer are really dedicated to where should we do that or that mechanism. Should it be inside the codec or should it be outside of the codec? Should it be, should the API be aware of this or not? That's the key questions. So the first question is, what type of codec should we focus on? So, of course, we need to have something which is as generic as possible. That's the title, that's the goal. But we need to take an important decision. Should we consider both block codes and sliding window codes or not? We discussed that together. If we look at what has been done in those 4 implementations, you will see that 3 of them concern focus only on sliding window codes. There is only 1 of them that encompasses both block codes and sliding window codes. And we discussed, and for the moment we came to the conclusion that we should focus on sliding window codes only. So this API should be an API for sliding window codes. If you disagree, then please come and explain us why you have a concern. Because that's an important decision we need to take now before going further into details.
Dave Oran, so you're going to have to excuse me. This is probably a really stupid question.
Oh, no.
Which is, can't you do a block code by using the API for a sliding window code, and on every call, a disjoint window gets shifted?
Yeah. We had that in mind some point of time. Of course, a block code is a sliding window that does not slide. So there is some equivalence from this point of view. But when you go into the details of the API, for the moment, we didn't find any satisfying manner to manage both in a unified way. There are differences, technical differences, and when you try to address them, you will quickly enter into problems. And for the moment, we have no solution. Okay. Maybe there is one, but I didn't find it.
Muriel has a question.
Yeah.
Yes, I just wanted to echo Dave's point and maybe expand on it a little bit. So as you know, there is, I'd say at this point, a pretty large literature sort of bringing together block codes and sliding window codes. One of them is, of course, the overlapping blocks, where in effect the coding is done in a blocked fashion, but these blocks overlap sometimes in sort of a constant step away from each other, sometimes in a non-constant step. So that is sort of very much a link between block coding and sliding window. The other aspect is that sometimes you get implementations which start out as a block code, but then because of the way acknowledgements are managed, really start looking very much like a sliding window. So I think it's important to realize that there's really quite a continuum with, again, I think a considerable literature behind it that I wouldn't want us to dismiss.
Yes, there is a continuum, but as I said, when you go into details and you want to design an API, it's not that easy to find a solution that encompasses both block and sliding window codes that is attractive and simple, that remains simple, even for particular case of block codes. So it's a very practical question, and we need to go into practical considerations here. But yes, for sure, there is a continuum.
Muriel, tu as une question?
Yeah, no, I just wanted to say that, yes, of course, we want this to be practical, but I believe that there have been some implementations out there. Now, I wouldn't want to speak for other people's implementations.
Yeah, yes.
Okay.
If you have an example, then we would like to see this. Sure.
There's a large
it's
literature out there. Again, I haven't particularly looked at that. But I think that that's just something that we would want to look into.
For time, actually, I think I'm going to cut the questions until your end of your presentation.
Sure.
So that because we're
Yes. For the moment, it's okay, but yes.
for sake of time, because you still have a lot. You haven't done the last line actually. API
Yes. Last line, important, of course. We of course can consider both end-to-end and situations when you have recording inside the network, because it's pretty easy to address from the API point of view. So let's do that for sure. Second question is now one of those questions. Where should you do that feature? Should it be inside the codec? Should it be on top of the codec? So should the API consider this or not? So that's the first example. Should the ADU, so the ADU is the application data unit, the message from the application, let's say. Should this ADU to source symbols mapping be done inside the codec or on top of the codec? Should the API consider only source symbols, repair symbols, which is the conclusion if we do that only on top of the codec, if we do this mapping on top of the codec, since in that case, the API will only see and consider symbols, or should this be inside the codec, the opposite solution? We had some discussion. There are impacts in terms of implementation, complexity. This mapping is not trivial. There is some complexity associated to this mapping. So it's, once again, an important question. So we came for the conclusion for now, after discussing that should be done by the caller outside of the codec to keep this codec as simple as possible. There are consequences, of course. Comment? No?
Just a quick question. By outside the codec, do you mean above the API or outside the codec but below the API?
Yeah. So this is the drawing. So on top of the codec means outside of the API. So here in this example, if we do this mapping inside the protocol, inside the application, let's say, that uses the codec will only consider symbols, because this mapping will be done before entering.
So coming back to the format discussion just for a second.
Yeah.
Would the symbol format be below the API or above the API?
The symbol format, if you mean by a symbol
Within
format,
this
the
draft
header. Okay,
and
so
that
this
draft.
is the header. There is a specific question for that.
Oh,
it
okay.
will be on top of, within the application. That's the proposal.
So if that's
I
a
will
quick
discuss it.
comment. You'll have to demonstrate that you don't get multiple data copies when you do that.
Yeah.
Okay,
So that's exactly this question that you mentioned. Where should we process, create, and parse the packet headers, the symbol headers?
Symbol
So-
headers, not packet
Um,
symbol headers.
Yes, in some way. There are connections between the two anyway. But yes, the headers, let's say. So there are consequences. This is once again a very important question, because when you design a fake scheme, this is not only the codec part, the encoding and decoding part, this is also the signaling part that is required to use this codec. So this answering this question will also answer the question: does the codec does the API implement a fake scheme or just a codec? So we had some discussion, and for the moment, our position is that once again we keep the codec as simple as possible, focusing only on encoding and decoding, and leave this packet header manipulation, creation, processing, parsing inside the application on top of the API. So that's our position for the moment. Next. Fourth question. I still have 5 minutes. Should the codec, once again, same type of question, should the codec take into consideration timing aspects? So if you are manipulating real-time flow, there is a limited validity duration for each of the piece of information that you will send to the receiver. So should the codec, should the codec and the API be aware of those timing aspects or not? Once again, it has implications on the API point of view, because there are typically with sliding window codes, where this distinction between decoding window, which needs to consider timing aspects, and linear system size, which does not consider timing aspects. So there are consequences. Once again, I don't want to go too much into the details, but there are implications. So we add, once again, our discussion. And for the moment, our position is that this should be done inside the application on top of the API. So the API and the codec will also only focus on coding and decoding. Fifth question. This is especially a question for you, Dave. And you mentioned at previous IETF that it should be nice to take into consideration hardware constraints. That's a very good point. But unfortunately, none of us has any sufficient experience in the domain to see what it means, what are the implications, and therefore to design this in an appropriate way or avoid some mistakes that might be done if we don't keep that in mind. So if anybody has an opinion on this, examples, hints, then we would appreciate that. We will ask the question on the list anyway.
Muriel, question from Muriel.
Yes.
Muriel?
No. Okay, so let's continue.
So just one quick high-level comment.
Okay.
You don't want to structure the API such that if you have a split implementation, that you're forced to pass every symbol independently across a hardware-software boundary. Because you'll blow the latency out. So if you're doing the coding on an FPGA, and the application's running on the CPU, if the API is passing individual symbols back and forth, uncoded symbols to coded symbols over that API between the hardware and the software, right, it won't work very well. So you have to consider an API in which there's inherent ability to do batching.
Mm-hmm.
Right? So that the interaction, so that your control interaction with the hardware can operate over a reasonably large number of input symbols and output symbols.
Okay, that's the key point to keep in mind. We'll probably get in touch with you to clarify more precisely this. But yes, thank you very much. So, quick final slide to summarize. We need to make choices. Those choices have implications. It's not obvious to see what are all the implications of each of those choices. We need to have some practical experience for that. But I think we could do something nice. From what I've mentioned before, it's clear for the moment that the codec will only focus on low-level encoding and low-level decoding, and therefore the FEC scheme will be broader than just what is inside this codec, and the API, as a consequence, will not be an API for a FEC scheme, but an API for a FEC codec. So now well, next step is to come with a first proposal for next IETF. We'll see if we manage to do that, but this is work in progress. Any more comments?
Any more questions?
Comments? Thank you. Thank you, everybody.
Questions? Muriel, you had a question and it disappeared. You still have it? Okay, good. Oh, Emmanuel. And then Muriel.
Quick questions because just on time.
That's all. Okay, or maybe later on the mailing list because it's going to be a bit long, maybe.
Sorry, Emmanuel. We cannot hear anything. Can you repeat?
Okay. Yes, I said maybe on the mailing list because it's going to be a bit longer.
Stop. Does not work.
Okay.
Back up from your mic, maybe.
You don't hear me? Hello?
No. Back. Yes, that's good.
Okay, I was sure it was working. Back. Again?
Again. Move les.
Yeah.
Hey, recule. Yes, c'est bon.
Is it fine now?
Yes, much better.
Okay, sorry. Just a quick question. Are we sure that we don't need to have time stamping and time field inside the codec?
For the moment, this is our opinion, but if you have good arguments, then we can discuss this.
I thought simply about the timestamp inside TCP. Sometimes you need just to be sure what kind of information you retrieve, or maybe to estimate end-to-end delay or some stuff like that. For the sliding window, is that a problem?
Yes, but you should do that in the application, in the protocol, not in the codec.
Yes,
the codec, when a new source symbol has been decoded, then the codec will give it back to the application, and so the timing will be that the current timing when this happens. But if you have maybe you are running.
Sure. Let me think about it. We will discuss.
And let's go on the list. Yeah,
let's go on the list for that. Muriel, if it's 30 seconds, it's good. If it's more, send it to the list.
Okay, great. I just wanted to point out that this is actually an answer, I think, to the question that was being asked about whether there are implementations. There are FPGA implementations that my lab did with the lab of Anantha Chandrakasan, our current Dean of Engineering, on FPGA. We also have done this in with sponsored by the Semiconductor Research Council. There is a chip implementation of network coding, and there are a lot of. And by the way, answering Emmanuel's question, there is no timing in any of those at the codec level.
Okay. If you have references and persons that we could contact to get more information on what it means to have a hardware implementation of such a codec, then that's nice.
Contact me, and I'm happy to send you the published references.
Well, actually, Muriel, I think it would be better if you were sending that information to the list, because I think we want to make sure that the whole group gets the information. So the list is the best way.
Yeah.
Thank you. Okay.
Next.
Nicolas?
Yeah, Nicolas.
Ouais.
Tu t'en sors?
Ouais, je m'en sors, mais sont où les slides? C'est la prochaine? Je peux continuer.
So, hello everyone. This is a 5-minute discussion slot for speaking a little bit about the interactions between network coding and congestion control. So I'm presenting that on the behalf of Emmanuel Lochin, who couldn't make it here and sent me the slide yesterday. So I'm doing my best. Basically, the problem is that the thing is interactions between network coding and congestion control could be done in many working groups at the IETF. So why could we start it here? First is that we have already network coding and congestion control interaction solutions existing. And also the discussion needs to start somewhere anyway, then see where it go forward. So the objective of these 5-minute discussions that may be worth having on the list afterwards is to see whether we make a group document here or we just speak. I don't know. I think the main high-level discussions are whether can we and should we, for example, when you have a network coding recovery, and basically the loss is not due to link layer or transmission layers issues losses, but more on congestion control losses. Do you actually consider that in the as a congestion signal, and how you actually impact your congestion control scheme as a consequence? And also depending on, I will present after a discussion, a use case draft on network coding and satellites, and the problem that we see that depending on the use case, because network coding is a building block that you can deploy, and depending on the use case and the traffic you're considering, you have lots of different possibilities. And the same happens here. Sometimes there's no point in actually having interactions between these two, congestion control and network coding. So next slide, please. It's just example on what is exactly at the moment. For example, we have things that are at the user space, and we already have Quick with some sort of network coding. We can do some middleware network coding as well. And in the kernel, these are examples of the on what you can basically be below a transport layer and have no interactions at all with TCP. You can have as well. So basically, there are lots of things happening and lots of proposals with interactions between network coding and congestion control. And the thing is, do we have material to make a draft in this group or not? Do we want to? And so that's what Emmanuel wanted to ask to the group, I think.
Yes, the question is what to do next. Should we enter into this work? Should we? Is there any critical mass for doing that? What should we put inside? Well, all of them are open questions.
Hello, Ian Sweat, Google. I think it would be worth writing a document, although I think it's important to get the scoping right, because I can imagine, you have things like coding for satellites that may be unaware at the application layer, like Quick and TCP might not actually see the coding, but it might still interact with the congestion controller that's running end-to-end because, for example, if you're running cubic, like you don't see any loss, you're like, oh, everything's going great, and you like get some huge window and suddenly it explodes and goes very poorly. So it may almost be an interaction with like AQM as a secondary layer. So I guess trying to figure out what the scope is it only, end-to-end coding, or is it end-to-end coding as well as like in-network coding? And doing both, I think, is useful, but it's a bigger task. Certainly not something I would sign up for, but I think is worth doing.
Yeah. There are always discussions about, coding versus congestion control. And if this document could, explain, among other things, that, okay, we can do things in an intelligent way, where coding will not negatively impact congestion control, break everything, then that could be also one of the goals.
So there's one additional complexity that probably ought to make it on somewhere on the slides, which is some coding schemes attempt to dynamically adjust the level of coding based on what types of errors they're seeing.
Exactly.
And if you're not very, very careful, what you'll wind up doing is you'll increase the amount of coding when you get congestion, which of course increases the number of packets that are sent, which in turn increases the amount of congestion. So if you have a static, coding, you'll do different things if the congestion control is above the coding than below the coding. But if you have a dynamic adjustment of the coding level based on a perception of loss, things get really complicated. And I don't know the answer, but there's not enough expertise either in a classic congestion control transport group or in a coding group like here to deal with that. So I think it's a really good research problem, and we need expertise from both sides to deal with it. I'd sort of like to add the dynamic coding problem in there because it's going to hit us.
It's true that among the proposals on the other slide, there are lots of them that basically, for example, you use ECN signals when you know that there has been a loss recovery, so you send.
Yeah, I saw the draft on using ECN. It's very nice, but it's only part of the solution.
Exactly. Yeah.
Spencer Dawkins is responsible area director for the Quick Working Group. Those guys are encoding everything. And then, well, anyway, some of them are sitting in this room, so I know there is communication back and forth, but you perhaps dropping a note to the Quick chairs would be a useful thing to do, just to make sure, so that they can make sure that the right people are involved from that side. Thank you.
Thank you. Okay. I mean, that's what we meant, that we wanted to. Yeah. We don't know where we have to start the discussion, whether here, there. So that's what.
Spencer Dawkins, member of the IRSG. We will, between the IETF and the IRTF, we will find you a place to have that discussion if you need to have it.
Okay, that was a good introduction for the next talk, which is Oh, there's a talk. Yeah, I'm sorry. I don't see.
Quick comments.
Oh, I just wanted to say that I think this is a great idea because there are a lot of things that you can do without touching the congestion control, and then really interesting interactions. So I think it's a
Great.
great.
Thank
Okay,
you.
thank you.
Thank you for the support. Okay, great introduction to the next talk. Ian, you're still there? And while Ian is coming, has everybody signed the blue sheets?
I haven't.
Okay, so then do you know where the blue sheets are? But you can do it after. But anyway, in the meantime, is everybody in the room assigned the blue sheets? And where are the blue sheets?
Yeah, I sent you 2 versions. Sorry. I think the second version.
Oh, I loaded the new one.
Okay, thank you very much. Appreciate it.
I think the one that ça s'appelle il y en a un qui est un.
You guys don't know one. I know.
There's
Ouais,
no
ok,
one.
attends. Ouais, attends, je suis perdu là. Non.
C'est pas dans-
Sorry, I'm lost. Things are not going on as I expected.
J'ai uploadé.
Ah oui, non, mais c'est sur. Ok, oui,
Non, 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 je l'ai uploadé sur.
Oui, oui, d'accord, mais j'ai pas
C'était
le.
marqué upload. Ça s'appelait upload des. Upload de.
Oh. Sorry, this is a late, a late contribution, and therefore it's not on my laptop. It's on Marie-José laptop because I received this just before the
Non, mais écoute,
meeting,
pourquoi.
and then I need to go to the official website. Sorry
je
for
l'envoie
that. Non, c'est pas ça.
Should be in your email as well.
Yeah, but okay.
Okay. Yeah.
J'ai uploadé.
Oui, oui. I need to open a window.
One day we're going to invent something that will know what we want to do and it will just fetch it. You know, like things will know. What?
Swim. The universal protocol. I'll do what I mean.
Yes, yeah. Hein?
Va où c'est marqué les lettres. Va où c'est
Yeah.
across. C'est la croix.
Yes.
Non, l'autre.
No,
Ça,
it's
c'est celle-là.
working.
C'est pas la nôtre.
No,
Right, that's the one we're
close. Yes.
Yeah, c'est ça.
Yes. At least. Yes.
Okay, thank you. Okay.
Sorry.
So there's another kind of conversation about network coding in Quick. We've talked a little bit back and forth about like how this could be done in a V2. A V1 was done in Google Quick a long time ago that didn't really work out for various reasons, which I talked about in previous sessions. So I want to say that for the record, you know, I know a fair amount of Quick as a transport. I'm not a coding expert. So as much as anything, this is an effort to kind of design an architecture that would fit best with the Quick transport. Next slide. So the top level requirements, number one, we don't want to actually change Quick V1. The current proposal is to use the extension mechanism where we would negotiate one or more forward error correction frames for use inside Quick as additional frames. Talk about that later. Should be agnostic with respect to what's actually the code that's being negotiated. So the current proposal is that you would be able to offer up multiple extensions. Ideally, they would all have the same base frame, but the actual forward error correction algorithm being used would be different depending on the extension type. So, and you know, potentially you could even negotiate like 2 or 3 if that was suitable. So this design mostly focuses on coding taking place within a stream or across multiple streams. So kind of focusing on the data actually being delivered. There's a few slides later about kind of why we're shifting in that direction. But the key thing is not all streams actually need to be coded. So, you know, doing it on a packet layer is less natural. Control frames usually aren't as latency sensitive. And it also may just fit with the Quick extension mechanism a little bit more seamlessly. And it's going to be end-to-end is the design. So Quick is end-to-end, pretty much everything else. Quick is encrypted end-to-end. And so doing coding end-to-end is the most natural thing. One could certainly implement a middle box that, you know, shared the ephemeral keys and like did coding within the network. That seems extraordinarily challenging, and I can imagine it actually be worth the effort. But you know, this just fits into the design principles of Quick much more naturally. And yeah, coding happens before encryption because it's within the encrypted payload. Next slide. So yeah, so some streams may need to be coded, some may not. So we're going to negotiate what kind of algorithms are available in the quick handshake. The PR I mentioned is one way to do it. And then the application itself will decide, like, this is very high priority, or maybe I have extra bandwidth or something, and try to provide some signal. Even in Quick today, we actually have what's called like a bandwidth probing mode, where like DBR, for example, has a mode where it's trying to look for more bandwidth. And as has been mentioned before, when I was talking with Lars, one could, use extra bandwidth and throw FEC in there to see if you have more bandwidth. Question?
Quick question on the encoding on top of encryption rather than below encryption.
Within encryption, but yes. Oh, of not doing that, you're saying?
Well, there's a trade-off, and I'm just wondering about it. And you could check. Something I may not understand. In the way Quick does encryption, do you have to reorder before you decrypt?
No, you do not.
Okay,
So-
then my question's irrelevant.
Yep. Okay. Next slide. The idea is to define a new Quick base frame that all of these various coded approaches would use. The simple version would have a type, a stream ID, an offset into the stream of what you're trying to protect and recover from, and then a data length of the number of bytes of code. And within it, obviously you need the second layer of framing of like whatever your coding system actually relied on. And an extension would be to have a repeated stream ID and offset, and that would allow you to span multiple streams, which could be particularly compelling for cases when your streams are very small. So that's kind of an issue of data mapping of like whether you're using a large number of small streams that could be easily canceled, or whether you're using large streams and maybe using some other unreliability mechanism we haven't actually defined yet in Quick. Next slide. So the original idea was that we were going to code packets because that's what you lost, and so therefore that's the easiest thing to recover. Sort of fits into the general Quick packet recovery scheme. However, we can't change the packet numbers, or we don't want to in such a scheme. But we do want to allow things like non-consecutive packet protection because maybe some packets are important and others are not for previous reasons. We can have issues with things like path migration, which cause huge jumps in packet number space. And so in general, the interaction between the packet numbering and the coding kind of could become a little messy in some edge cases that we thought we didn't really want to deal with. One of the worst issues is actually that all of these schemes have overhead. It's not necessarily huge, but it is some amount of overhead. And in order to have kind of one coded packet that protects, some number of other packets, the natural thing is to just add the extra overhead to the one that has the coding frame. However, that would blow over your MTU if you're not careful. So then you have to underfill a huge number of other packets, which also in turn reveals that you're using coding to the path and is generally just kind of a little bit messy. Multipath makes this sort of worse, not better. So we're kind of gravitating away from that, even though it seemed to originally like the most obvious way to do things, because that's how Quick loss recovery works. Also, Quick loss recovery is moving away from being packet-based and more oriented around the data that's within it than TCP-style loss recovery is anyway. So the new idea is to use an extension frame that references one or more streams. As I said, only protects latency-sensitive data. The nice part about an approach like this is Quick already has send and receive buffers that you can base this on, and so to a large extent, it's fairly easy to access the existing buffered memory kind of as part of your input to do the recovery. So it flows pretty natural from an architectural perspective, or it should. That's the idea. The new idea, which is suggested by Christian Hutema, also an active participant in the Quick working group, was to, at least for prototype purposes, just define an extension frame that replaces a stream with, some combination of actual data and coded data, and, define a way on a per algorithm basis to make that happen, and just kind of do whatever you want. Nice part about this is it really allows you to use any type of code you could possibly imagine. It avoids interaction with Quick's loss recovery because it's not a stream, so Quick's not going to naturally retransmit it for you. It's just going to declare it lost, and you can do whatever you want. And yeah, it allows maximum experimentation because it sort of offers nothing. But it also, means you have to kind of roll your own to the maximal extent. So maximum flexibility and maximum work, I think, on the part of the experimenter. Next slide. So yeah, the first step is we need to kind of figure out how the extension mechanism, A, we have to land the extension mechanism quick. B, we have to figure out how we're actually going to use it to negotiate multiple different coding schemes. We need to choose one or more sample codes. Raptor is now, the original version of Raptor is not encumbered anymore, is my understanding. So that certainly could be an option. Reed Solomon has open source implementations, which are fairly good. Obviously those are two very different types of codes, but both would be sufficient for the purposes of a demo or something. And then implement in PicoQuick or one of the various other quick stacks. PicoQuick is Christian stack, and he seemed interested in actually writing code, which would be an extremely helpful part of this process because my extra time to write code is sort of limited these days. Next. I'd like to agree on an API that we're going to use so we can allow multiple different types of forward error correction algorithms to be used within Quick. I would ideally, we define kind of a base infrastructure of this is approximately how you should do this. And then we, just different algorithms would negotiate. I don't know if, Vincent's proposed API is the right one. It certainly, as you talked about, does restrict some types of codes. So it's not as expensive as it could be, but it also may be fairly applicable if we're focusing on protecting stream data. So I think that's something we kind of need to work out through some combination of experimentation and feedback from this group and the Quick working group and others. And next steps. Is this a research group item? Is this something we eventually want to migrate to Quick? Or last option is maybe we should just run some more experiments and come back in 4 or 8 months and tell you what we found. That's it. I think there's, yeah. So, and thank you for your help writing the document on the coding aspects. Yeah. So.
Thank you. Any comments, any suggestion? There's 3 questions here, so who thinks the
Actually, I'd like some feedback also on the transition from a packet-based to a stream-based kind of direction and whether there are any reasons people believe that's a bad direction, as well as suggestions on the API question. Like if we're going to have a very flexible API for plugging these algorithms into Quick, do you think something like Vincent's document is the right direction? If not, should we be considering something else or 2 different documents or 2 different frames? Like some feedback there would be great.
I don't have an opinion on the packet versus stream. I mean, Quick is a stream protocol in most aspects. So, it had better work well in modeling the I/O as streams. The comment I wanted to make is things may work out a lot better if we try to do this at the same time and in coordination with the way we do multipath. If those 2 things start happening in parallel without sort of tight cooperation, there's all kinds of interesting questions if we decide to do the coding on a stream basis and multipath is not binding streams to paths, but trying to split streams across paths.
The vision is it will
again, there's a sort of like a quadratic complexity around how you choose the level of coding you use. So it might be real nice if these 2 things, the multipath and the coding, weren't so modularly separated that they didn't know about each other.
Yeah, that's true. I think they're going to be. Most of the development will probably coexist in terms of time frame. I think these are both.
I'm just saying this is a good moment to move forward because once Quick V1 is out the door, there's going to be, I think, a sort of burst of effort on multipath, and there should be a burst of effort on this at the same time.
I would agree.
Yeah, Lars, I chair Quick, and so if you want to do anything with this year, the quick working group is not the place, right? And I think Ian fully agrees as an editor, in the sense that we want
a contribution from my
so
co-authors.
we're trying we're trying to ship quick version 1, which is single path HTTP only, and we are trying to push everything away. Dave makes a good point, right? So there's synergies here. So there's a lot of activity on quick that will sort of begin to happen once V1 is sort of stabilized. That doesn't mean, the RFC is out. It probably is going to happen before. My personal, so I don't really know if we're going to make the November deadline, but my guess is sort of within the 3-month window around the time when we're going to ship it finally to the ISG, people will already start to think about multipath. And probably they already start to think now, right? There's the Levant guys, for example. But the working group has no mind share for any of this at the moment. That shouldn't stop you guys from thinking about this, right? But don't even think of sending us email about agenda time before. Yeah, well, drafts don't take mind share. Nobody reads them if they're not related to the actual. So, but alignment with multipath, I agree with Dave, seems to make sense, or at least sort of not making sure that they're not like fighting all the time would, I think, be the lowest bar. Yep. But yes, not this year, and probably not even in the first half of.
And that's why we're talking about it here, which I think is the right choice. Hopefully.
Yeah. Hi. Good morning. So Cedric Sino from XPway. So I'm working for. I'm coming from a different world, from 3GPP world, and we're using Raptor code, and we're using Raptor code for RTP, and we are doing a different stream. So differently, the approach where you've got one IP or one stream, which is just for the coded data, makes sense, especially if you want to keep kind of compatibility with RTP. So this is something that we experiment in 3GPP.
Okay.
So maybe that's
that's another thing to consider.
That's a good
idea.
Yeah.
Thank you. Muriel, it was on the phone.
No.
Oh, no?
Okay, thank you very much.
Thank you.
Let's move to next talk. We have 6 minutes. We are 6 minutes late.
So hello again. So this is just a status on what we have been doing in the network coding and satellite draft since the last IETF. We have this 6 minutes left, so I will be quick. Next slide, please. Basically, what I wanted to show in this slide is that we had initial objectives with this document, and we have been doing something different. In fact, we wanted to contribute to a generic document in architectural where you can actually place network coding and so on based on an example on satellite communications. But the fact is that there are too many possibilities that what we have been doing is, at the moment, is present different use cases where network coding are interesting for satellite communications, and also having a separate discussion on how we could actually further deploy these mechanisms at a wider scale. So next slide, please. We have had one good review from Tommaso, and also we have these different use cases, and I will go through these use cases now. And we have been, there wasn't much in these use cases before, and now we have lots more context, and there are some missing points here. So next slide, please. As we don't have much time, I think I will just show you here what we have in the document, but mostly focus for the end of the presentation where we may have some discussions. But basically, this is the use case when you have two satellite terminals which are under the same beam and that are speaking to each other. And basically, satellite terminal are send A, send A, B, send B, and then the satellite combines the two and sends the combinations of the two signals on each of them. Basically, that can result in huge bandwidth savings. And that has been demonstrated in ISMS 2010. This is another use case that we have identified where basically you have multicast server, and because satellites business for satellite industry is still on using the actual huge capacities they have. With one satellite, you have large beams that you can cover lots of terminals. But the problem is that when you want to have a reliable transmission, this is the type of mechanism that you can use. And basically, we have two terminals that are on listening to the same multicast server, and both terminal can send what packets they haven't been receiving, and then on the multicast server, you have some network coding mechanisms that resends what have not been acknowledged by everyone. This is already implemented in Norm, but actually it's not the same coding technique that can be used in Norm. Another one refers to what has been presented in TCP/M a couple of days ago, where basically you have this sort of concentrator that lets you have a hybrid access of multiple technologies. So there have been lots of research activities on how you can actually use network coding so that when you have packets that are lost on one path or the other, you can actually recover them by using. You don't have to wait for the packets to be actually, it's lost to be actually acknowledged on the path to actually resend it. So basically, you can have lots of high-level gains on the end-to-end. This is something that is missing in the current version of the draft, but we have been discussing with Scott earlier this week. Basically, this is the use case of delay-tolerant networking. For those who don't know, these network architecture might be somehow different to what you may know. Basically, to make it quickly, we have the bundle protocols, and underneath we have these convergence layer, and we have different possibilities of including network coding in this type of architecture. Either we do it on the blue boxes below, which is underneath a convergence layer, or you replace the actual convergence layer and you include network coding within that layer. So that is that makes a pointer to the discussion we just had before on the impact of the congestion control mechanisms, because in the convergence layer, we may have some congestion controls. And so if you include network coding in these layers, that may have an impact on the relevance of the mechanism. And if you look at more the layer 2 transmissions, the problem is that when you have ARQ retransmission, network coding may, that's the same trade-off that we have, where basically you send initial redundancy, not knowing the actual channel capacity. And so you use capacity you don't have, or you either send too much redundancy. So that's the kind of discussions we plan on having in these use cases in the document. And then I think you can go next. That's another use case we have. That is one for which we actually already use network coding in satellite systems today. When you have, so this is basically we have the satellite terminals, the satellite, the physical gateway, the access gateway, and then some network functions. Network coding can be applied at lots of different levels for this use case. And for what you have today deployed, when you have moving users, you go under, for example, in Marsat systems, when you're moving and you have your signal is interrupted because there's a tree or whatever, then you have burst losses that can be recovered by using network coding schemes at higher layer than the physical layer. And also, there was this interesting presentation in the plenary on satellite communication. And basically, we are actually targeting for very high bandwidth optical links in satellite systems. And that's what the future is envisioned at the moment. And in these bandwidths, we have huge variations. So introducing network coding as a physical layer may not be enough in the near future. So that is actually interesting for even fixed SATCOM telecommunications tomorrow. That's also another use case. I think the last one that we have, basically, you have, when you typically have an internet satellite access over the Europe, you actually have dozens of gateway, and sometimes where you have channel conditions are bad, you want to switch from one gateway to another, and if your gateways are not actually properly synchronized, that may result in packet losses, and network coding could be applied at different layers here as well to actually improve and cope from the losses that may happen when the gateways are not synchronized. This is an illustration of what we have been doing with Emmanuel Lochin. In CNES, we have an open platform for hosting whatever SATCOM experiments. So if you want, it's free, it's available. We have lots of different access. And this is a SATCOM internet fixed access. And we have been comparing the throughput of TCP communication with and without network coding. And basically what we can see on the right is the TCP good put over the time. With the TCP with Tetris, you have actually a better usage of the channel capacity. We were lucky because when we were doing the experiments, it was a rainy day. So that's when we actually have varying capacity. And so we had losses and it was not actually perfectly working. And so we show that with network coding, you have a better good put. That being said, we don't speak about the fairness of the congestion control because it's clear that when you send more data, you have a better good put. But we didn't assess the impact on the whole other users that don't enable congestion control. And I think that's more interesting for the congestion control potential soon to be document. And I think that that's it. We have had a discussion also in the document on the deployability of network coding schemes for SATCOM systems. So basically, we have presented high-level architecture of a multi-gateway SATCOM system. And what we tried to discuss is that basically depending on where you are on the LZ level, the network coding scheme that you would deploy is not the same. And basically what I wanted to say mostly is about the virtualization infrastructure. What we are doing in SATCOM at the moment is the same as what is happening in the, I forgot the name of the draft that is pointed out here. But basically we have virtualized infrastructure where we can actually deploy network coding functions easily. So that is where I think there are interactions between what is happening in other working groups working with virtualization, but that's it. What we have not actually fulfilled the initial objectives that we had on the document. What we're actually doing is show lots of use cases where network coding is important and interesting for satellite communications. We also have some discussions on how we could easily deploy these schemes. And we think that we are actually not sure at the moment how to progress further on this document. Should we detail the use cases and go much more into the details on what network coding schemes is relevant or not? I think it's not the case. Maybe what we could do is look at the network coding proposals in the group and see which ones are relevant and could be used for the use cases we propose. And we have been trying to find some industrial interest because we are not industry. And we are interacting with SATCOM equipment providers or SATCOM operators to see if they are interested in collaborating in this draft. Okay.
Yes, a quick question, Muriel, or comment?
Oh, yes. No, thank you. That was a very, very good presentation. I really liked the taxonomy of the different problems. I just wanted to say I might go ahead and share a white paper that we have written regarding one of the points that you brought up around dealing with failures that are not manageable by the physical layer codes. I'll be putting that. We also might want to share, if with the chair's permission, we have a paper with Jason Cloud, who's now at Dolby Labs, and also with Doug Lath of Trinity College Dublin on network coding for SATCOM, lessons learned. And I think that paper, which we presented a couple years ago, does go into a lot of these things. And I also wanted to point out some of the testing that we've been doing with Steinwolf and also with ISPs in the Pacific to provide for bandwidth-starved cities, towns, and islands in the Pacific network coding-based satellite internet connectivity. So, I don't want to deluge the group, but I'd be happy to share those. I think they're illustrative of many of the problems that were so nicely presented in this presentation.
Okay, thanks. If you can share, yeah, that's great. Thank you.
Absolutely. Yeah, this is all published. I'd be happy to. Thank you.
Thank you.
Thank you. Next. Okay. Okay, thank you, Nicolas. I thought there was no comment, no question, so yeah, we can switch next presentations. Okay.
Hello, I'm Kazuhisa Matsuno from IETF. So now I'd like to talk about the current status of this document titled Network Coding for CCN and NDN. So at the previous meeting at the Network Coding Research Group and ICN Research Group, we introduced our initial draft regarding its background and the content. So then we got some questions and comments regarding a relationship between the coding information header and the security envelope, and comment about the design choice regarding who determines the encoding vector to generate the coding packet and its impact on latency, and the comments about the clarification of the objective and the scope of this document. So according to this feedback, we've made a quick update, which includes the editorial update and adding the clarification regarding the payload encryption with or without coding information. And we added a case where a producer statically decides the encoding vector. And we also describe the potential challenge for adopting the convolutional coding. So this objective, the objective of this draft is to consider research challenges as well as we want to gather and show the research results to establish a common understanding about network coding for CCN. And we want to clarify the requirements for network coding for CCN. And hopefully, we want to provide useful insights to network coders in order to make it easier to apply and implement network coding into CCN and NDN. So now, actual protocol proposal to satisfy the requirement is out of scope of this document, but we will propose actual protocol based on our papers in other draft. So here's the table of contents, current content. So in section 2, we introduce CCN and NDN background and its basis. And section 3, we show the existing prominent research results and clarify the benefits of using network coding in CCN. And we modify the section 4 content naming and publish operation according to the feedback from previous meeting. And we also added a new description regarding the adopting commercial coding as a research challenges. So there was no description about network coding plus payload encryption in the previous documents. So we added the case of we added a case where coding information is specified in the meta field, not in the name, and the information is encrypted together with payload. And we described its feature that is this may make it more difficult to re-encode at the intermediate node in terms of the computational overhead for decryption. Okay. And we clarify the scenario where a producer statically decides encoding vector to generate a coded packet, and we describe its feature. In this case, latency can be reduced compared to the case where a consumer determines encoding vector to be used. But in this case, content request need to obtain the names of the coded packet prior to the request. It's a drawback. And we added we modified the challenge for adopting commercial coding. We added an example and the benefit of adopting conventional coding approach on end-to-end basis. And we consider research challenges such as how to apply it into CCN in terms of the signaling aspect, and how to exploit the CCN and the end feature to enhance performance gain. And we need to discuss the feasibility and the practicality. So now we are going to design the convolutional coding to apply to apply into CCM. So next step, we need to enhance the content of the security and privacy and the routing scalability in more detail, and maybe we need to identify the potential research challenge if useful, and then we're starting introducing actual protocol proposal, and we hopefully show the experimental result in the next meeting. Thank you.
Questions?
Okay, thank you. Okay, I have a comment regarding security and privacy. Those two items are with respect to the use of network coding. This is not in general for ICN, if I understand correctly. You confirm? Otherwise, that's a big topic. Yeah. So this is specific to the use of network coding. Okay.
Yes, actually, my point was similar. By the way, great presentation. I enjoyed it. Yeah, I think it'd be interesting separately from this to look at the convolutional network coding. I mean, the original paper on random linear network coding by Ho et al. Did actually consider the more general case of convolutional coding. But there was a lot of recent work actually with Ning Tsai and others that we have done on decreasing the kernel size for these convolutional codes. And I just wanted to basically just echo that I think it'd be interesting to look at convolutional coding by itself. You know, of course, I think it's fantastic to look at it in the CCN context, but maybe doing that separately, and I'd be happy to participate in that. I just wanted to mention that. Basically, just echoing the chair's comments.
Okay, thank you. Just before you leave, Kazu, one more question or comment. Last time we said, okay, it was great to have this shared work between our group and the other group. How does it work in practice? You still present this in both? You didn't mention anything.
Seems to be working fine.
Okay, that was to have your feeling. Okay, thanks. In that case. Okay, so now we are on time. Last presentation. This is also a shared work between two research groups.
Okay, yeah. So this is also is a bit different perspective of network coding, and it's a first attempt to share this work between this research group and the network function virtualization research group. So the authors are Romano, who is a protocol expert, Luis Contreras from Network Operator, and then me in the system and coding. So it's a bit interdisciplinary. So, okay, I will go quickly. So the motivation of doing this perspective of softwareization and virtualization is because we will now discuss that the network coding can be seen as a function, a network coding function, and can be seen as a function provided as an operator service, possibly on demand. So then we will show, we will provide our arguments for this, then example use cases proving the usefulness, and then our proposal for softwareization and virtualization, for which we propose some architecture. And then also we would like to discuss the links to these other working groups and other drafts, and next steps. So motivation. So what we have, our basis is that network coding can be seen as a function in CF. So the point is that under the network softwareization point of view, we have network functions which are basically pieces of software which should be efficiently designed, deployed, and executed. So So far, network functions were just a small set of functions, and black box oriented was not clear how they could be implemented. But now they are being has a great development by different vendors for many types of applications and well beyond traditional networking functionalities. So then this is our point. Network coding can also be designed as a network coding function. So the why we'll explain now, and the how it will be the rest of the slides. So why? So there can be many explanations. Our preferred explanation is that there are two distinguishing features in network coding that explain why seeing them as a function makes sense. So first, the transversal application, which we are witness here in this research group, which means that the network coding can be applied over packet flows at different layers and many network scenarios with different degrees of distributed or centralized coding operation. Hence, with this transversal application, if we see network coding as a network coding function, this would allow us implementing network coding in all above cases, just thinking of them as software pieces that moreover could be reused. So then we could have a versatile network coding way of applying, which can be also modular and provide scalability. And second, also a distinguishing feature of network coding is that we can think of it as doing a mathematical flow engineering. What do we mean? We mean that with network coding, we can see packet flows interpreted as mathematical objects. As we know here, you look at it in the symbol perspective, micro symbol perspective. We can also see it as in the flow sense. So then you can see this, that the network coding will transform mathematically the flow and induces properties in this flow. So if we have this perspective, and if we design network coding functions, would allow to interpret the network coding function as a flow engineering service, which then can be given by network operators and possibly on demand. So this is why then in our case, we do have use cases. So this, and as use cases, we have two very different use cases that also proves our case, our arguments. For example, we have this European Space Agency funded project, which is called SatNet Code. In this case, we do a very typical application of network coding for improving the reliability of multicast. We use re-encoding, and we assume overlay hybrid networks. So then you can see that on the left, we have just the satellite as a physical bent pipe, so it's almost as it doesn't exist from network coding point of view. And it may happen that for this case, we have very, very few logical nodes that need to re-encode. Then on the right, you have that the satellite is also a re-encoder. But what is of interest here is that you see that we need to control the operation of network coding all along the topology, and the topology itself needs to be optimized. So all this controlling thing is what we can address with softwareization, virtualization. Next. Then you can see we have yet another completely different use case, which is the use of network coding for efficient caching. In this case, while in the other case it was an overlay network, we have here broadcast also hybrid network where satellite is. And in this case, the use of network coding is for the efficient multicast, so you can locate populate the caching efficiently. So it's very different use cases where our ideas can be applied. Okay, so then this was just to argument why what we are saying might be useful. And then we do have a proposal for the softwareization virtualization of network coding. So for our proposal for softwareization is to have visible internal logic as opposite to legacy black box network functions, meaning that we can have a well-defined functional software architecture that this software architecture maps directly to softwareized network architectures. This implies centralized control, which is a little bit opposite to very distributed packet networking. Now, even if we propose this visible internal logic and agreed functional software architecture, this approach also enables interoperability between different network coding functions, because you can still have blocks that are proprietary. So, but if we do so, we can prevent the stagnation of networking ecosystems in the softwareized networking, due to that everything becomes proprietary. So what we do is like we have an architecture that we all agree, and then there might be common blocks and proprietary blocks. That for the softwareization. For the virtualization, we focus on integrating the software architecture so that you can easily integrate in virtual network functions architectures. That by doing this, of course, you can take advantage of a unified computation approach to computational network resources. Okay, so then these preliminary ideas are already in this draft that we propose to have to present here and in the other network research group. So what we have proposed is that, as you can see, this presentation is different to the previous one. Why? Because here we also need to apply system thinking, not only protocol thinking. For this reason, it's important to distinguish in which domain we are, because we also need to see when we are in the coding domain, meaning design of code books, encoding the coding schemes, which performance has the codes. Then we have the functional domain, which is the one we're talking about here for the architecture. And finally also the protocol domain, because at some point we have all this architecture, but we need protocols to be operative. So, what in this draft in particular, what we look at is at the functional domain. What are the functions that the network code needs? So in this domain, is when we make real what we said before, that we propose a visible internal logic and internal architecture that we will prove that can be mapped directly to SDN and BFN architectures. So for this software architecture, what we have done is to distinguish, again, different functional, like main functional components of the softwareization of network coding. So at the moment, what we have distinguished are these three, which are, first of all, the core functionalities, of course, which is coding, recoding, decoding functionalities. And so we look at them at functionalities. So, of course, this means that with our functions, we should be able to instantiate different network coding options. For example, different types of coefficients, random, structured, regenerative, or hybrid, and different behavior at finite length. For example, different admissible network coding schemes. And no, because the second one is important, because the second one is flow engineering functionalities. So this means that we will be using all these types of network codings. We will choose depending on which engineering functionality we want. It could be congestion control. So that's why I wanted to make the point, because then I meet you in your discussions before. You know, we are like a logical level above you, where all what you do is useful for us. We will be using this. So this might also mean that we could give you requirements, for example, right? Look, we need all this, let's do it. And then finally, we have the physical abstraction functionalities. This is what makes the virtualization possible. Yeah. So this is just another, since we are system thinkers, we need blocks, we need figures. This is just a very simple way to see that we have, in the software architecture, we have the functions that will map directly to the software-defined network architectures and then the physical abstraction functionalities for the virtualization.
1 minute?
Yeah. Okay. So then I will not go into detail. We do have already some proposals that map our software architecture next to the software-defined network. We are working with the network operator on this to have. So the key point here is that even you should distinguish the nodes which will re-encode and the nodes that only transport the coded flow. So these are logical differences that need to. We don't have solutions for that. So this is what we are looking into here. So just finally, what are I just now described ideas. So identified links for sure with the virtualization research group. And the moment we also intend to have the same presentation here and there, at least to start with, and then also with drafts. One option would be this, that we give our requirements, what we would need from this higher logic point of view. But I would like here what feedback I may get, what is useful or not.
Thank you.
That's all. Thank you.
Deborah, one of the things that I would have expected to see in the section on the flow engineering is the trade-offs between open loop and closed loop control. Because most of these naive network function chaining sorts of things only consider open loop control. And for a lot of the things that are classically done with NF, you don't need closed loop control. It may be really important to get closed loop control for a coding application where there's where you need to sort of like optimize between an encoder and decoder. Needs to be a feedback channel, stuff like that. Is there any thought in terms of the flow engineering part of that as to how you represent the open versus closed loop control?
Not yet, because that's very good input. What you are talking about is already to make it to work out flow engineering. But we are still at the moment to identify which flow engineering we want to look into. And so the how comes after, and this is a very good input.
Other questions? Thank you.
Okay.
Yeah.
So I guess we finished slightly 4 minutes at a time, which is great. What?
I can waste the rest of the time.
Well, it's fine. You can, if you be my guest. So anyway, I think it was a very nice meeting. I think both Vincent and I are very happy with the progress of the group. And
yes, we have 7 documents for the moment.
Yeah, and all of them are progressing, which is great. And
transfer some of my CNRG documents over here.
Sure. The more the merrier. They may not be related, but that's fine.
No.
And so anyway, so I guess we'll see. We'll hope to see all of you in Montreal, and again, continue the great work because there's a lot of progress happening. Thank you.
Thank you.
Thank you. Thank you.
Moi, j'ai un meeting avec Gary Gory.